Types. What is it? So it starts with talking about non-disjunction. What is non-disjunction? It can cause an abnormal chromosome number. All right? Abnormal chromosome number. Gametes with too few chromosomes usually don't survive. In some cases, gametes with an extra chromosome do survive. After fertilization of this results in an additional chromosome. Could anybody tell me an example of something they know where somebody gets an additional chromosome? And what it would be?
Down syndrome.
All right. Down syndrome. What's that?
It's when you have the mental disorder.
Maybe some black belt.
But don't you have like more chromosomes than you need?
Yeah, more than you need. Where? Trisomy 21. So instead of 2 21s, you have 3 21s. Does anybody know any other genetic disorders you could possibly have? All right, autism may not be. There's a lot of different reasons that occurs. Yes. It would be a genetic disorder. Talking more about like when the chromosome number changes. How about this? Has anybody ever heard of XXY?
Yes, I've heard this.
What is it? What do you think somebody with Klinefelter disease would have? What do you think that person would be like? All right, so the deal is it's actually a female with male characteristics. Russian Olympians in the 70s actually had used women that had Klinefelter's disease to win all the events back in the day. And now in the Olympics, how do we test them? What do we have to do? Does anybody know? You have to do genetic tests. You have to do a karyotype to see if there are any abnormalities. Otherwise, they get disqualified along with all the doping and everything else, like that guy Backstrom, Nicholas Backstrom. Anybody heard of that?
Yeah, it was his allergy.
Sure.
It was allergy medicine.
Of course it was, yes. All right, so we're going to talk about a bunch of those. All right, going to talk about a bunch of those cases where we do have something wrong genetically, okay?
What's the disease where you have like the same sex, like two?
Hermaphrodite?
But you're born with.
You are born with both, correct. So you'd have we'll talk about hermaphrodites as well. Okay, next, meiosis. A cell with a diploid number of 2. So this is normal. Boom, boom, XX, we got the 4. And then what happens, non-disjunction, instead of them splitting, they're going to go into the same egg or sperm cell, and then you would have extra amount of DNA in one of those sperms or one of those egg cells. All right, so non-disjunction of homologous chromosomes in meiosis 1. You can take a look. We have a little non-disjunction occurring. It could happen in meiosis 1. It could happen in meiosis 2. And it just goes through and shows you the different things. N+1. So we have extra set right here. Extra set. We lost the set. It came over here. This set came over here. Let me just draw it for your happy, joy, convenience. This guy was originally over here. This guy was originally over here. So that's a type of non-disjunction that happens in the beginning of meiosis 1 and then comes down and has the effects on the gametes, the sex cells. And then again, you can see it's the same exact thing. We just had one simple non-disjunction. This guy actually moved from there to there. Of course, okay? So here's the difference. Non-disjunction of homologous chromosomes in meiosis 1 leads to this. Non-disjunction of sister chromatids in meiosis 2. You have to know what it's going to lead to. So if it's meiosis 2, meiosis 1. All right, so just kind of make a note of the differences that you're going to get. Which one is worse? Which one? Which one's worse for you? So the meiosis 1 non-disjunction, you think? Oh, you all agree. Raise your hand. All right, so if you have non-disjunction in meiosis 2, how many normal chromosomes do we have? 2. We have 2 normal sperm cells or egg cells. How many normal do we have in non-junction of homologous chromosome 1? None. We have none that are good. 2 that are good. So meiosis 1 is going to be worse, non-disjunction in meiosis 1 than meiosis 2. Okay. Karyogram or karyotype. A photograph of chromosomes arranged in a certain format to determine if a chromosome number is normal. All right, so it's a karyotype is a photograph, a picture of chromosomes. All right, they're arranged in format of 1, 2, 3, 4, 5, the chromosome number. That's how they're typically arranged. Your sex cells are the bottom right to determine what they are. And how do we obtain those? They're going to be in the next box there for you. So this is karyogram. I don't know why it says karyogram. Karyotype.
So they're the same thing.
Karyogram and karyotype are the same thing. Okay, a picture of chromosomes arranged in a certain format. Where do you find your sex cells? In a karyotype. Sex cells, bottom right of picture. And we're going to do a little activity on this. So what you're going to have is 1, 2, and you're going to have the chromosomes lined up. You can see those chromosomes that are there. All right, da da da. You have that lined up by chromosome number. And how do we check those? How do we obtain those cells? Chorionic, villi sampling, and amniocentesis are the 2 ways to obtain them. Number 1 in the box. Number 2, we stop cells in metaphase and squash on a microscope slide. We're going to stain the chromosomes to see the banding pattern. Then we'll take a picture from the microscope, photo micrograph, cut and paste them. Really all they're going to do is cut and paste them. In the world now, what they can do is manipulate them on the computer like a little game. You can just take it and move it. You don't have to cut and paste anymore today. Now they actually can do it on the computer. And you're going to, in chromosome homologous pairs based on size, banding pattern, and centromere location. All right? And arrange pairs by size and centromere location based on karyotype format. Sex chromosomes are last. All right, so these are karyotypes. All right, a photomicrograph, a picture taken under a microscope. I love that your class gets cut short every day. Every day. Oh, and then everybody's else, oh, you gotta get blah, blah. No, can't. All right.
Does this class end?
9:25. All right. Okay. Any questions on that? I'm waiting. Don't worry. I know you have to write a lot. I was gonna sign it and then go over it, but I don't think it would take too much time. So I'll go over it right away.
Or 6, arrange pairs by size based on
Based on karyotype format.
Yeah.
Arrange pairs
This space is really small.
based on size and centromere location based on karyotype format. Sex chromosomes last. Sex chromosomes dash last. Under 6. I'm sorry, it's a small space. I got nothing to do with it. I'm just the
Well, no, they put the space in the wrong.
yeah. Those people. Miss Cunningham, she'll do that to you. No crazy. Sorry about that. Alex said it's okay, so if he can handle it, you guys can handle it. Yeah.
Alex is too legit to quit.
You can show them to me later. You're good. Okay. All right, now, guess what we got there? Anybody know what that is?
Foot.
Not a foot. Not a foot. Anybody else?
Fetus. No, it's
Fetus.
fetus.
Oh, it's
That's a vagina, along with a uterus. Okay, a vagina and a uterus. Okay, that's what it is. So we're trying to figure out how we can get chorionic villus sampling. All right, so what they do is see that needle coming in, they call it a catheter. All right, and it's going to go in and actually take some of the fluid that is surrounding the fetus. They're not actually harming the fetus. It is a dangerous proposition to do this, but everybody does it. It's part of, this is what you do when you get pregnant. It's what we did when Lucas, we had Lucas, we did the genetic makeup, so we knew if there was any problems or not. So it involves taking a sample from the villi, find projections of the placenta embedded in the lining of the uterus, done between 8 and 10 weeks after the conception.
Why is it dangerous?
Oh, you get hurt the fetus? Yes. That goes right in the box. Right in the box. All right? Again, you're going to have the ultrasound transducer, which is going to lead you to, and if you ever see it, sometimes you don't see much. Sometimes the kid's butt is right on the ultrasound, so right on the camera, so the butt's just sitting there. And it's really great. How many people experience like a younger brother or sister with mom or dad when you were growing up that you can remember? Yeah, Lucas used to just punch or kick, and it would just be literally come out like a, and it would come out like 3 or 4 inches. Yeah, it was my wife says pretty painful. Not as much as birth, but and no matter what any man tells you, passing of a kidney stone is nothing near giving birth. So don't let them read you the riot act, ladies. Giving birth is it's a wonder of life. A wonder of life. All right. So, anyways, okay, moving on. So now, amniocentesis. All right, baby's a little bit bigger. Taking a sample of amniotic fluid, the protective liquid contained in the amniotic sac, done between 14 and 16 weeks. All right, so again, big needle, basically right through the abdomen. You do not have to do this. This is one we elected not to do because we did the other one. All right, this would go in the other box. All right, this is one we elected not to do. So again, you'll have the ultrasound, the picture, make sure you know where the baby is, go in with a large syringe and pull out some fluid. That's why we didn't do it.
Is it basically the same thing as a...
Is
Yeah.
that like a risk?
Yeah. Yes, it's a risk because babies, guess what they do? They move.
You can't sue the doctors there.
Of course. But that's the problem with our society. Everybody sues everybody. Saying. Yeah. All right. So again, you're going to pull out that, get the genetic material from that. Does anybody
would the
ever
baby
wonder
die?
how's it? Could get hurt, could die, yes. Anybody ever wonder how the baby's breathing right now? The tube's got like it's like a respirator. It's like oxygen's coming right through the tube.
Isn't that like the umbilical cord? Not the belly button. Like the belly button?
So they breathe through the belly button.
Yeah.
They're like fish right
Oh
now.
no, that's the food.
Blood in the mom's stomach.
They got gills.
They have gills.
Wait, are you serious?
Yes. You didn't know that?
So
You really didn't know that? Yeah.
I'm
Now,
a fish.
you are not different from any other living animal on Earth up to about 24 days after conception. You're exactly the same as every other animal on Earth. It's when you start differentiating. It's a great study, embryology. It's a great study, an emerging field. Anybody see that the Washington Post published that we're now, FDA is allowing human embryological Stem cell research, 3 babies, something. Yeah.
So they just killed 3 babies.
I'll show it to you in a minute. All right, these procedures can identify the baby will be born with an abnormality, however, cannot indicate the severity of the condition, some small risk, damage to the fetus, possibly resulting in a miscarriage. Now, the other thing I told you that I strongly suggest you do by the time that you're of age, 10 years from now, right around then, probably some of you maybe a little less, some of you a little more. You want to keep those umbilical cord blood stem cells. You definitely want to keep those stem cells because there are more and more diseases being cured from those umbilical cord stem cells. What are they going to do with the umbilical cord if you don't want to keep it? Yeah, throw it in a trash bag. That is the precursor to all life and the cure for anything that your son or daughter could develop in life is those stem cells. So if there's anything you get from this class, save your umbilical cord blood, mom or dad, whatever it is. You know, force it upon your spouse or whoever that may be. I really think that you'll actually send me a letter when you're 30 and it did maybe change somebody's life. That would be something good from this class. You don't keep it. There's companies that keep it for you.
So do you think how much of most of our
You
parents
don't
have
like take it
those
home and
stem
put it in your
cells?
freezer.
What is it? Is it like expensive or is it?
The upfront cost by the time you do it will probably be $500. Like right now, it's like $2,000 and a maintenance fee of $125 a year. But one is good for all your kids. You don't need to do it for every kid. If you do it once, you're good.
So you have yours saved.
Hmm?
So do you think like most of our parents kept their stem cells?
They didn't do that when you were born.
No.
You know?
So like, if one of the kids gets sick, does it just run out of stem cells after that one that gets sick? Or?
Well, don't forget there's about 3 trillion. You'll be all right. But the other thing is this is the other thing that you tend to conveniently forget, that those stem cells, ACL tears, muscle tears, broken legs, you can get to the point where we're going to inject you and it'll regenerate that stuff in like 3 weeks and you'll be good to go.
So if I had my stem cells after coming, I
Could have been good to go. All right. Don't blame your parents.
You got a lot of seconds?
Instead of what? They can regenerate it, yeah.
So they can do that now?
There are a lot of companies that are doing that now.
Is it illegal?
No. I told my mom to get it done on her, she had an injury in her shoulder. I told her to get it done, but it's just a tad expensive right now. It's for over $10,000. Because they can remember, you can grow them from your own stuff. All right? But they're not as good as in building. What are ethics? Because like he asked about, well, what about my mom? How the stem cells? We already learned that you can grow your own stem cells back. They're just not as good as the pluripotent ones. So, and then the process of growing them and getting them where they need to be, a little bit longer than just, oh, I'm going to pull mine out of liquid nitrogen storage. What are the ethical issues and what do you think might arise for these practices? Anybody? All right. Well, we're not talking about that. We're just talking about the amniocentesis and the chorionic villus sampling. What is it? Why? Okay. All right. Possible hurting the baby. What else? Okay, but think about it as the other way. What if you found out there was something wrong with your baby?
Then you're going to kill it.
Right, and you might abort it. And, those are your ethical issues with this situation. Okay, or you might want to go in and try to genetically alter the baby, which is not God's plan either. Correct? But I always say the same argument. The same argument I've always had. Back when before I grew up, but everybody would say, well, we wouldn't go, if God wanted us on the moon, he would have put us on the moon. We shouldn't be on the moon. And what do I say to that? I say very simply, God gave us the ability in our minds to get to the moon. So he did give us the innate ability to get to the moon with our brains. Correct? All right.
715
All right. Pick a photomicrograph of chromosomes before the karyotype is done. Little picture there. A human with Down syndrome. Down syndrome. Check that out.
Yeah, this is really sloppy.
Yeah, I mean, better.
Were you guys right?
Oh, I suppose I was
Where are you reading that?
That's all I need. I don't need That's fine. Yeah, that's okay. Yeah, we're just gonna go, I already know what I already had a plan for now anyways, so.
Okay. Down syndrome, trisomy 21, non-disjunction during the meiosis tetrads of chromosome 21 do not separate properly, leading to 3 copies of one cell. All right. Now, how long can somebody live with Down syndrome? Not as long as a normal person, but now with the advances in modern medicine, you can get to a point where living a longer life. Can people with Down syndrome go to high school? Yes, absolutely. Absolutely. The prevalence of Down syndrome is growing at a rapid rate in the United States, having to do a lot with diets, a lot to do with lifestyle choices, all the different preservatives and different things you're putting in foods that you're consuming, in my opinion, is leading to a definitely increase in kids with Down syndrome, autism, and many other things.
Really?
Absolutely. Think about it. How your rate of autism in 1985 was 1 in 1,000. Now it's 1 in 70. Okay, 1 in 70. All right. Now what has happened since then? Oh, we have here's a shining example. Are you ready for this? Don't be grossed out, but you know it always comes to a poopy day. In college, they came up with these fat-free chips. When I was in college, that had Olestra in them. All right. Olestra was the fat-free. It wasn't really making the chip. It got the fat out. We put Olestra in there, and it tastes like that, but it wasn't fat. Well, I enjoyed the chips, and my roommates and everybody enjoyed the chips. Oh, these are great, blah, blah, blah. And then 6 months after that came out, a study came out that it caused anal leakage. All right? What does that mean? That you couldn't control your bowel movements because of the Olestra would stop the control of your sphincter muscle. So there were cases all over the United States of incontinence in teenagers, 20-somes, 30-somes, and just think if they do that, and oh, all of a sudden there's this new sugar-free stuff, and what's the sugar-free, and what's this? You know, the phenylalanine in your diet, sodas, all right, all aspartame, all these things that are in your drinks and everything that are not natural. Well, it has to have a direct correlation. We all consume it. I mean, I'm not saying I don't. I definitely do, but the point is, you always want to watch what you're taking in because you never know what it's going to affect on your future babies or so forth. Okay? I mean, it's definitely coincides. All right? That's the same with genetically enhanced crops or cows or beef. You know, grow them faster, clone them. What's the deal if you clone a cow? You have more fat on the meat than actual meat, but it grows faster. It's growing faster by adding more fat. You consume that 90% of the time. You're consuming, almost at 95% of the time, you're consuming something genetically modified or an ingredient that is not natural to go in your body.
That's Chipotle.
Exactly, not Chipotle.
See, that's what they said.
I had Chipotle yesterday.
All right. I had that too.
Smelled like sugar.
Down syndrome.
I
Down syndrome. But what I'm saying is, you're not going to see a change in the amount of Down syndrome, autism, Asperger's, you name it, you're not going to see a change until there's a societal change back to more of the, natural foods, changing of your diet. Which, guess what, folks? It's probably not going to happen in America. We like our chips.
Well,
We
did
like
you
our
hear
sodas.
the new study of them trying to ban trans fats?
The trans fats, trans fats have always been around. Trans fats are natural. That's the deal. People think, well, trans fats are natural. Well, yeah, vegetable oil, I need to tell you, that's natural. You just don't want to, drink vegetable oil, right? You don't want to go home and take a vial of Cheese Whiz and inject it into your vein or your artery, right? But that's unfortunately what we do. You don't want to go home and have a sleeve of crackers, put Cheese Whiz on every cracker, and drink 2 Gatorades. Probably not good. That's how I eat typically. Yes, Kerrigan.
So people with Down syndrome, and they're not in kids.
All right, correct. Now, well, no, that's incorrect. They can have children.
They have Down syndrome?
Not necessarily. Not necessarily. Because guess what? You have the crossing over, you might not get that. Remember, that doesn't mean all their genes are messed up. Are their sex cells messed up?
Yeah.
Look at the picture. Tell me, do the sex cells look messed up? No. They just have an extra trisomy 21. Now, they're not sterile by any means. They can definitely have babies, and they can have completely normal babies. All right? Characteristic facial features: short stature, heart defects, susceptible to respiratory disease, shorter lifespan, prone to developing early Alzheimer's and leukemia, often sexually underdeveloped and sterile, usually some degree of mental retardation. But they're not, often not. There's definitely a number of people that have Down syndrome that have had babies, yes.
But what is it that makes them all have the characteristic babies?
That's just the extra chromosome. The extra 21 chromosome, that's it. Why? If you want to figure out why, you'd probably make a lot of money of why that chromosome causes those features. You'd have to look at the loci, all the alleles, all that thing, and do a lot of research on it. That's not my forte. All right? And I don't think that that's been really studied to that point. Down syndrome is correlated with age of mother, but can also be a result of non-disjunction of the father's chromosome 21.
So does that mean younger moms?
Older.
Older moms?
Be honest.